Hi there. So question 3, just a reminder that question 1 and 2 are the same on 2A, 2B, 2C. I've already done 2B many months ago. So we're starting off on question 3 here. So a stone is dropped from a bridge into a river. The distance, d meters, that the stone has fallen after t seconds is modelled by d equals 4.9 t squared. Complete the table below. So this is just substitution, and make sure that you are doing 4.9 times by t times by t. Do not do 4.9 times by t and then square it. That won't work. So our values we get 0, 1.225, 4.9, and 19.6. That's the two easiest marks you're ever going to get. Okay, draw a graph of D against T on the grid below. So this wasn't a nice diagram to draw. I'm going to struggle with this, but we've got 0, 0. We've got 0.5 going to 1.22. Now in the middle is 1. So what would each of these represent? Each little square is going to be worth 0.4. So we've got 0.4, 0.8, 1.2. It's 1.225, so I'm just going to put it slightly above there. 1 is at 4.9, which is just below 5. So we can estimate a little bit here. 1.5 is roughly at 11, which is in the middle. And then 2 is at 19.6, which is spot on there. And then we need to draw... Oh, this is going to be tough. Come on. Oh, do you know what? I lost it at the end. But it's fine. I don't need that bit, really. There we go. Okay, there's our graph. So that's, again, 2 more easy marks. Now, the stone hits the water when it has fallen 15 meters. Use your graph to estimate the speed. Now, we've got distance and time, speed, distance, time, distance divided by time. Funnily enough, that's up over across. So the gradient is what we're looking for here when the stone is at 15, and that is in there. So what we need is the ruler, and I'm not going to be able to do it spot on here, but I can tell you what the mark scheme says for the answers. Look at that curve, that's awful. So anyway, what you're doing here is you're drawing a tangent, and my tangent is, geez, this is such a bad line. I'll draw it in there. That's, you know what you're doing. You've got your line, got your curve, then you draw your straight line against it. So again, let's pick some coordinates from my one. When I was doing it earlier, it's just not the same, is it? It's roughly the same. We've got 2 is at what looks like 19 now. Crikey. So this is miles out. And then I'm going to say 1.5 is at 10. 1.5 is at 10, which means it's 19 take away 10 divided by 2 take away 1.5, which gives us 9 over 0.5. So my gradient is 18, meaning that it's 18 meters per second. Oh, do you know what? I've smashed it. We're okay. Now, if you follow that process, you'll find, and it's looking for an answer between 15 and 19.5. Oh, managed to get it in there. That's super. So that's how we get that answer for 3C. So 18. I'll put that there. Thank you. Right, calculate the average speed of the stone from the moment it's dropped until it's hit the water. So what have we got here? Distance and time. Distance and time. So it's gone 15 meters. How long has it taken for that to happen? So it's kind of happened about here at 1.75. 1.75. So I'm going to come out of stats mode. That paper's gone. 15 divided by 1.75 gives me 8.571428.571. So I'm going to put 8.57, and the mark scheme is looking for an answer between 8 and 9 for your full marks. So there we go. That's question 3. Like the video, please like the video. Put a comment on saying how great this video was, and of course, share it so we can get some more subscribers. Let's build the channel. Let's make sure people now and in the future are passing core maths. See you at question 4.